Imagine a place where the stars stop twinkling and galaxies decide to call it quits. What secrets could be lurking beyond this newfound boundary? Are we on the brink of unraveling the greatest cosmic mystery, or is this just the beginning of a whole new chapter in our cosmic adventure? Buckle up, because the James Webb Space Telescope claims to have found the end of space itself. Yes, you heard it right, the final frontier might not be so infinite after all. But hold on a sec, how can space have an end? Wasn't it supposed to go on forever? Let's dive into this astonishing discovery and see what's really happening. When I first heard this news, I was excited to unlock one of the many mysteries of the universe. The James Webb Telescope revolutionized our understanding of space. In just 12 hours of observation, this wonder showed us things that made us squint and scratch our heads. Imagine how big the universe really is. Let your imagination run wild and think as far as your mind can reach. Now let's find out how much the James Webb Space Telescope can actually see out there. Hop aboard our fictional superfast spacecraft as we head to the edge of our solar system, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We have passed 100 Australian dollars, and here we are at the edge of the heliosphere. After this point, we enter interstellar space where Voyager 1 and 2 ventured. We are now approaching the Oort cloud, a wall of asteroids 200,000 Australian dollars from Earth. It is sparse, and we easily navigate through the asteroids and enter total darkness. Passing the stars and planets, we reach the edge of our galaxy in minutes. No more interstellar wind, just bright dots from other galaxies mapping our path. We understand that our universe is not infinite. Its boundary is 10 billion light-years away. There may be other universes. A primordial supervoid a billion light-years across may be a sign of a collision with another universe. But how do we get to these other universes? Black holes may be the key. They are mysterious, warping both space and time. Some scientists even suggest the existence of white holes, which are the opposite of black holes. The idea is that they can lead to other universes. Remember Little Bang in 2006? That unusual burst of energy may have been a small white hole that was destroyed almost instantly. Now let's talk about the Andromeda Galaxy, which moves at a speed of 68 kilometers per second. Don't panic. It won't crash tomorrow, but when it does, things will get interesting. We may witness a collision of stars, or perhaps our solar system will be thrown into dark space like a tennis ball on a string. Front. Galaxies merge and the black holes at their centers begin to dance. Eventually, they merge into a supermassive black hole, releasing energy and an active galactic nucleus visible for millions of light-years. Then we have the South Polar Wall with a quadrillion stars 500 million light-years away. There is also the Hercules Corona Borealis Great Wall, a flat superstructure 10 billion light-years across. And don't forget the Great Quasar Cluster, 4 billion light-years across and 6.1 billion times heavier than our Sun. And then there's the observable universe, more than 500 billion galaxies, each containing billions of stars. But wait, there's a billion light-year wide void called the Eridanus supervoid, or cold spot. Some believe that it is the result of a collision of universes where two bubbles collide and tear the material apart. Now imagine the universe as a giant bubble, and there could be an infinite number of bubbles. Wormholes or portals inside black holes can be shortcuts between these universes. Imagine folding a piece of paper to connect two dots without crossing the entire sheet. That's the idea. Speaking of black holes, one can survive falling into them if it is supermassive. The effect of gravity gradually increases, avoiding the dreaded spaghetti. Who knows? Surviving the fall could end up in another universe with different physics.
Although it's just a wild theory right now. Imagine you are outside on a clear night looking at the stars. It might seem like they are evenly distributed, right? It turns out that this is not the case at all. These stars are actually part of something massive, a giant cosmic web that connects galaxies across the universe. Astronomers using the James Webb Space Telescope have just found the oldest link in the cosmic web ever discovered. In two papers published in the Astrophysical Journal Letters, researchers explain this incredible discovery. They used data from the James Webb Space Telescope to reveal a massive cluster of 10 densely packed galaxies spanning an astonishing 3 million light-years. Shani Danieli, an astronomer from the University of Arizona and part of the research team, could not contain his surprise and said, "I was surprised how long and narrow this filament is. I was hoping to find something, but I didn't expect such a long, obviously thin structure. It's like stumbling upon an ancient treasure hidden in a cosmic vault." This ancient thread of gas and stars dates back only 830 million years after the Big Bang, practically the infancy of the universe. And guess what anchors this huge thread? A supermassive black hole, of course. This black hole is no ordinary one. It is a very bright celestial body that acts as an anchor for this cosmic structure. The team behind this amazing discovery is part of the ASPIRE project. What is ASPIRE? It represents a spectroscopic survey of reionization-era biased halos. Nice name, isn't it? Their task is to find out how the earliest black holes affected the evolution of galaxies. And guess what led them to this ancient filament? One of 5 early universe quasars they looked at. Fan Wang, an astrophysicist at the University of Arizona and the brains behind ASPIRE, is pretty excited. This is one of the earliest filamentary structures that people have ever found associated with a distant quasar, he said. It's as if they've stumbled upon a cosmic treasure map that reveals the secrets of the early days of the universe. Now it gets interesting. Scientists believe that black holes played a crucial role in the formation of this cosmic network. Imagine that black holes act like magnets, pulling matter along with their gravity. But wait, sometimes they throw things far away in ways called cosmic winds. Gravity is the glue that holds these strings of stars and dust together, even as cosmic winds try to pull them across the vastness of the universe. So what does the future hold for this ancient filament? Well, scientists have a pretty cool idea. They believe that over time this cosmic thread will condense into a cluster of galaxies, a type of coma, about 330 million light-years away. It's like watching the universe evolve and create its intricate masterpiece over millions of years. When the Webb telescope aimed its mirror at the sky, it saw much more light and more galaxies than expected. Not just any galaxies, but big, bright galaxies. Now scientists are scratching their heads and coming up with different ways to explain this cosmic mystery. They are like crossroads, each leading to new questions and understanding. The first possibility: perhaps stars and galaxies formed differently and more efficiently in the early universe. Imagine dark space without many stars and galaxies, which makes it easy for them to form quickly. This is an unexpected but not a complete rewrite that we know of. Another possibility: what if the luminosity comes not from stars, but from supermassive black holes? Yes, you heard that right. Instead of a galaxy full of stars, we could be looking at galaxies lit up by these mysterious black holes. But if true, it calls into question what we thought we knew about how many of these monsters existed in the early universe. Third possibility. The most extreme possibility is that our understanding of the recipe book of the universe, called cosmology, is flawed. It's a bit radical, but it can shake up our understanding of everything. A fourth possibility, and then there's the wild card option. Maybe there's some unknown component of the universe that we haven't even considered. Why does all this matter? Well, it's about finding your place in space and understanding the story of how we got here. If we miss something crucial from this story, it's like trying to solve a puzzle without all the pieces. And the more we delve into this mystery, the more questions arise. Recent discoveries by the James Webb Telescope have given us a reality check on the size of the universe, as if we were far away. Scientists dropped a bombshell in a recent paper, claiming that the telescope detected glimpses of the stuff just 120 million years after the Big Bang, if the Big Bang happened at all. In addition, it questions the foundation of the basic cosmological model. The universe may not be as old as we thought, and Einstein's idea that it is infinitely old turns out to be wrong. Our intuition has failed us, and we begin to think that we really have no idea what is out there. The James Webb Telescope looks into space, trying to see as far as possible, but it can only reach about 46.5 billion light-years away. We call it the Hubble beam or the Hubble sphere. And guess what? Max 0647, JD, the most distant galaxy discovered by the telescope, lived only 450 million years after the Big Bang and is still on this Hubble sphere. Now our universe is like a balloon that keeps growing. It's not just expanding, it's accelerating. Outside the Hubble sphere, the universe is expanding faster than the speed of light. This means that there are things out there that we will never see because the light from distant stars cannot reach us, even if we wait forever. So if the James Webb Space Telescope can't see the edge of the universe, where does space really end? In theory, it's about 46.5 billion light-years away, but it only encompasses the observable universe, a fraction of all outer space. So what is beyond that edge? More galaxies, stars, and cosmic wonders? Or is it just an infinite gap? The answers may remain forever elusive, allowing us to ponder the infinite mysteries of the cosmos.